Welcome to Cheap Controls. On this YouTube channel, I make videos on things that I struggled with, hoping to help you so you don't. If you like what you see, consider subscribing.
For this video, I'm going to tie some things I've done in the past together. I'm going to use an example where we're going to control a couple of heaters, we're going to read some temperatures, and we're going to do some feedback. It's going to be a limited feedback example, and when we get to the end, I'll explain what I mean by that. We're going to start in the Nextion. I'm using a 2.8-inch display set horizontally. For this example, it should be simple enough that this will be just fine. The first thing we have to add is a font. And I have a standard 24 Arial black I use. This project has involved 2 pages, and that way I can show how to access values from one page while another page is being displayed and yet still control the heaters. So the first thing I'll do is I'll add a second page. But just to keep the numbering scheme and the logic better, I'm going to rename these. So I'm going to name page 1 because it's the second page. I'm going to rename it to page 2. And page 0, I'm going to rename it to page 1. We're going to be using some global variables for this. And when you refer to global variables, you can either use the ID of the page, the 0 and 1 over here, or you can use the name itself. I prefer to go ahead and name them page 1 and page 2. That way it just makes it more logic when I'm doing my code. As I said earlier, we're going to monitor some temperatures. We're going to use 2 thermocouples and we're going to monitor both of them. And then we're going to use those values to control 2 separate heaters. For this example, I'm going to use 2 LEDs. I have a Nano set up down here, and then these LEDs are going to represent the heaters. This will be for our output. The first page is going to be more of like a display page where it'll show our temperatures in text and on a slider. So I'm going to add the things we're going to need for that next. We're going to need a number. So we'll need 2 numbers. We're going to need the 2 sliders. We're going to need a button to go to the second page. And we're going to need a timer. Sliders, we're going to change the orientation on them. Instead of being horizontal and going left to right, we're going to change them to vertical and go north to south. In order to set these and make them look identical, I'm going to use the settings over here. Since we're doing temperature and we're going to use the temperature in my house, which is around 80, I'm going to keep my range, my minimum value to be 70. And my maximum value to be 90, and then I'm going to have it originally set to 80 just to start up so that the line will be in the middle. And then I want the line itself in the middle, this line here, to only be 20 high, and that'll make this shrink. So it looks a little smaller in there. But I want to change my width to be 50 and my height to be 150. See how that looks. That looks pretty good. Now we're going to do the same thing on this one. So our value is going to be 80, our max value will be 90, our min value will be 70. We're going to set our width at 50 and our height at 150. Now we'll just put these roughly about the same. We could use these values as X and Y to set our heights and make them perfectly lined up. But for this, we should be fine. Now this button, we're going to set it to take us to page 2. And we're going to do it on release. For the timer, it's defaulted to execute every 400 milliseconds. We're going to change that to 2000 or 2 seconds. And that should be it to get us a good start for page 1. Now we'll go to page 2. For page 2, we want to set the value of when our heater is going to turn on and off. We're going to set that at 80 because I know the temperature currently in the room I'm in is in the mid-70s, so I can hold the sensor, put it up against a light, so we can get the reaction of the heater turning on and off. Even since I don't actually have a heater, we'll be able to simulate it pretty well. And the other thing is we're going to display the temperature, just like on page 1 where we show the temperature in text format. We're going to show the temperature in text format on this page too. So for this, we'll need a button to go back to page 1. We're going to need 4 number fields, 2 for to show the actual temperature it is right now, and the second one will be to show the value where we want to turn the heater on and off. We're going to have 2 text fields just to show which 2 number fields we're using for what. We're going to have a timer, just like on the other page. We're going to have 2 variables. That's going to be to hold the current value of the heater. That we'll be using for feedback. So I'm going to put them here now, but we'll come back to them later. I want to make sure these buttons don't line up. I'm going to go back to page 1. Yeah, it's more in the middle. Sometimes if they line directly up on top of each other, when you hit one, go to the next page, it will cause the other one to actuate. Now for our text, these are the 2 that are going to show the temperature. And so I'm going to put a label up here, but I'm going to make the label a little bit longer. We're going to have it temp 1 value and then temp 2. Stretch. And then for this one, change it to 25. Well, we're going to set these 2 boxes up to be keypads. So we're just going to put click box to change. All 4 of these variables are going to be global, so we can see them on the page 1. But these 2, when we click on them, we're going to want to have them show the keypad. So just click on here. And then it pops up this because it's going to add a page that is locked we don't have access to, but it takes care of a lot of that for you. When I first got this device, I didn't know you could do the keypad on the basic models. It's nice to know that feature exists. Let's stretch this out too. Set this box to page 1. Release. And since this is the temperature we're going to have it change on, and we have the value set the other one at 80, let's just go ahead and make these 80s too, so that the initial value will be 80. And for the timer, we're going to adjust this to 2 seconds also. We just don't want to flood the output with values. So this will just, my steady pace, 2 seconds per execution. Now these variables are going to be referenced to the different heaters, so we're going to rename them now. Call one heater 1, and val 1 will be heater 2. And these values we're going to want to use, we're going to be visible on the on page 1, so we're going to set them as global. So that way we'll be able to see them on whatever page we're on. We're going to start these and we're going to set them equal to 0, so the value will be 0. And since they're going to represent whether the heater is on or off, so when we start the Nextion is going to assume that the heaters are off. Now we'll go back to page 1 and get some functionality going. When you flip between the 2 pages, since these are not global variables, they're not going to hold their value. So when we initially come onto this page, we're going to want to pre-initialize the values in here and set them equal to the global variables on page 2, which would be N0 and N1. So if I come down to the programming section, we're just going to set H0 value, which is the slider, equal to N0 value, so we can see it in this view, and then up here so we can see the actual value in digits. We'll also populate N1 with N1 and N0 with N0. So this way when we initially come to the page, it will reflect what the values are on there. But as the values change and those values get populated on page 2, we'll want those values to come based upon a timer. So we're going to copy the same lines, and every 2 seconds we're going to display them here. So at this point, just to make sure I have all the coding correct, we're going to compile this. Looks good. We're going to run debug. And you can see that this is up here and this is down here, so something's not right. 80 and 80. So I have something that's not transmitting over correctly. I'm betting it's because 0 would be at the bottom of the scale, even though this is 70 to 90. And this is holding at 80, so it's not writing the right value. So let's go take a look at that. We'll just go into the page itself. H0 is equal to N0. H1.val is equal to N1.val. Should be fine. Maybe I didn't set the values right in here. Looks correct. We'll debug it one more time. I'm not sure why that's not going down to the bottom. It should be, because this is reading fine. Let's come back to it and see. Nope, it's still holding right there. We'll go ahead and send some data to it from the Arduino, and then maybe it will become clear. I'm going to take a minute to go over this code, because if you followed my videos at all, I've had a standard way of doing things, and in this video number 116, I'm going to make a change on how I have some standard variables in here. And the first one is going to be this N character. It used to be that when I would send a string to the Nextion, I would put 3 lines of serial.write and then 0ff. But in order to speed that up, I'm going to have 1 line where I'm concatenating 3 characters together of the ff and putting it into 1 variable. Then I can just add that to the end. It'll speed things up, and hopefully it'll still make sense. There are other ways to do this, but I went ahead and put the 3 separate ffs so that it's clear that I am sending 3 separate characters. And then in order to do an asynchronous delay, I have this long, which equates to the milliseconds. And then this DFD is what I call data from display. I want to get the length of it as I collect the digits from the Nextion. And then I have the data from display, the characters themselves in this string. If I'm using a Nano, it only has 1 serial port. So I include the software serial library, and then I define serial 2 to be on pins 2 and 3. If you are using a Mega, you can simply comment out these 2 lines, and it'll work just fine because there is a serial 2 on the Mega. And then I begin the serial for both of these. Then in my main loop, I have a very simple delay. So every second it's going to run what's within here. And while it's not running within here, it will just continue to run this down here over and over and over. And what I'm going to do is I'm going to print out a 1 second async delay, just a message to know that I'm waiting every second and then I'm sending this. And if the Nextion is sending data on serial 2 and it's available, we're going to collect it and we're going to store it 1 byte at a time in this string DFD. We're also going to increase the DFD length variable by 1. The reason that I have this DFD length is for error correction. As I collect the characters, if I were to collect more than the Arduino was expecting, or too much of a length, because as I code it, I'll know how long my string should be. If I get some garbage for some reason, and in this case, if my length exceeds 8 characters, I'm going to run this reset the DFD, which means I'm going to set the length equal to 0 again, and I'm going to set the string equal to nothing. And then in this case right here, if the DFD ends with, so if I've collected characters and then it ends with this end character string, which is 3 FFs, means that probably something was sent from the Nextion, and that there was, usually means that there was an error, like you sent the wrong thing to an object that doesn't exist. You'll get an error code back, and so I want to print out what I got from them, plus just an error string to let me know I did it, and then I'm going to reset it. So that means I'm ready to collect data again. And both these are just kind of error checking. I'm going to start to include those in all of my projects. And just to test it, I'm going to go ahead and send it to the Arduino right now. And as you can see, I'm getting my 1 second async delay. Now for this project, we're going to add a temperature collection, and I'm going to use the Thermocouple, and I'm using a Max 6675 chip. So there's a library for that we're going to add. I'm going to do it right underneath this software serial. And in this library, we just have to include it. It uses a pin called serial out or signal out or data out. Sometimes it's DO, sometimes it's SO. And then there's a chip select and a clock. It's a 3-pin device. And I'm going to use pins 4, 5, and 6. And then I'm going to collect the temperature in this temperature1 variable. And then just so I can do a comparison, I'm going to take the last value and store it in this one. And I'm going to have 2 of these. So I'm going to have SO1, chip select 1, clock 1, temp 1 last. But then I'm also going to have an SO2, chip select 2, clock 2, temp 2, and temp 2 last. I'm going to use 7, 8, and 9. A lot of times I would just put the pin values in here, but for this video I thought it would be more clear if I went ahead and did it this way. And then I'm going to label a thermocouple TC1 and TC2. And for the rest of the code down here, I'm mainly going to reference TC1, TC2, and then the temp. You won't see these referenced again. Now in this area, I am going to add 2 pins to represent my heaters, which would be relays in the real world. But in this, we're just going to go ahead and use lights. I'm going to initially set them to high just so you can see that they're on. So we're going to use 11 and 12 for this. And then we just digitally write them to be high. I'm going to reset this. I'm going to set my milliseconds to be a 2-second delay, so it's like the Nextion timer or the Nextion display. And we're going to delete this line. I'll go over this real quick. We're going to do it in Fahrenheit. And in the Max library, it's read Fahrenheit. Temp1, which is just an integer, even though the temperature is read in a decimal point and a floating point, we're going to convert it over to an integer because the Nextion display doesn't recognize floating points. So for this example, we're going to do it just in integers. But I thought I'd go ahead and print out in the serial monitor, the local serial monitor, just to show this value right here is a float. And then I'm also going to print the integer value so you can see that too. And then that way we get an idea of every time it's printed here, we're also going to serial to print the value out to the Nextion display. And just like in the Nextion display, the code is the same. You'd send page2.n0, because remember on page 2, n0 is a global, the value equal to the temperature, which I have cast it by putting the string in front of it. I've cast it to a string. And then I'm going to add that n character, that 30fs. I'm going to do the same thing down here. Temp2 is going to be the reading in. We're going to print it in floating point and integer value. And then we're going to send the value to the Nextion display. So we should be all set to test this now. We should start getting the display up here. So we're getting it. 72.5 is 72, 76.1 is 76, and you can see we're getting 1 and 2, 1 and 2 every 2 seconds. I'll go back to the Nextion and we'll run it in debug mode. This is going to be a little difficult because every time I click on the Nextion, this is going to vanish and I got to bring it forward again. But the way you run this, if you're not familiar with it, is you go down to here and hit start, and it will start pulling in the data. You'll see it over here. And you can see page 2 and 0. And page 2 and 1, we're getting 70, 72, and that should equate to the values here. And then you can see that these are changing over here. This one still is not changing. I'm going to have to take a look at that. I'm not sure why it's not getting the data, but it doesn't appear to be. Let's go to page 2 and make sure that these are changing. Yep, and that one is changing from 73, that's changing from 76, but this is holding at 80. I wonder if I have these two switched around or something. I'll take a look at that here when we pull this out. But you can see I'm getting the values here, and then they're equating over to here, and at least this one's working. So let me minimize this down, and let me double check that I've got my boxes set in the right spot. So let's go over to page 2 N0, N1, N3, and N2 are correct. Let's go back to page 1. This is H0. I'll leave this in the video for now to show you that sometimes you do have problems with stuff like this. I'm going to delete this toolbox. This. Set this back to vertical. High of 50. Value of 80. 90. 70, width of 50, a height of 150. I did that wrong. The height I only want it to be 20. And maybe when I go back to edit this video, I'll see something. But as of right now, I'm still not sure. So let's go ahead and debug it and see. Oh, and now it works. I'm not sure what I did. Is there a chance that this was set to horizontal? But I'm just not sure. So let's go ahead and run this again. And we're good. So now what we have to do is when these values are below 80, we need to send a signal that turns the heater on. And when the values go above 80, we want to send a signal to turn the values off. And we want this to work whatever page we're on. We're going to send that signal based upon the timers. So go to page 2 first. I'm going to hide some of this so I can make it easier for us to see. Okay, so if page 2 N0 is greater than page 2 N2, we want to turn the heater off. Because it's too high, turn the heater off. If page 2 N2 is less than, turn the heater on. I've got heater 1 off and heater 1 on. And then we need a short little delay. Otherwise it's going to smash these things together because it's going to send this or it's going to send this. And what happens sometimes in the Arduino, if you send stuff too close together, it can get a little confused. So we're just going to put a 30 millisecond delay in here just to make sure we keep some separation. It may work without that. You can play with different delay lengths in your own if you want, but I found that it's helpful if you're sending two strings to have a little bit of a gap between them. Then we're going to do the same thing when we're going to send heater 2 off or heater 2 on. We want to copy the same code to page 1 on the timer. Now we're going to be sending the string over and over and over and over because it's every 2 seconds, depending on the status and the height of the value, it's going to send that to the Arduino. And you can see here, we're sending heater on. And now we're going to start this. And we're sending the temperatures back. I'm going to I'm grabbing heater 2 here. And you'll see that it will turn it off once the temperature gets above 80. What's interesting is at 80 exact, it doesn't send anything because remember it's less than or greater than 80. So when it sits at 80, it doesn't do anything. So now as the temperature goes back down, it will do the same thing, only it will change to on. So now we're going to go to the Arduino and look at the logic there so we can see the LEDs turn on and off based upon the value. I'm going to go ahead and leave this running because it should just be fine running in the background. Then when we change the Arduino code, it'll just keep going. Now down here, after we get the data where it says if02.available, then we add the string to DFD or data from display, and then we can check for cases down here. If it ends with those 0FFs, it's going to just reset it, or if it's greater than 8, it's going to reset it, which should be good now because our biggest one is heater 2 or heater 1 or heater 2 and off, which is 7 characters, so we should be good. So here we have our heater control. So if DFD is equal to heater on, we're going to serial print it so we can see it both on the Nextion display and on the serial monitor. We're going to reset DFD so it's set back to 0, so if another message comes in, it can execute one of these other ones. And then we're going to turn the heater on or off. In this case, we're turning it on, so we're going to write the LED on. Down here, we're turning it off, so we're going to set the LED off or low. And then we'll do the same thing with heater 2. Now when I upload this, I will switch over so we see the Nextion editor, we'll see the serial monitor, and I'll pull up the display for the LEDs. This is kind of interesting. I guess I went too quickly because this one here hasn't gone down yet. So it's still saying heater off. And you can see this LED down here. Move this up. This LED is off and this LED is on. So I'm just going to time lapse this a little bit to get to where this turns back on. And there, now it's come back on. I let it go a little bit just in case. Oh, there it went. It went back up to 81. So I don't know if I've got the sensor in a bad spot or it's just not coming down very well, but it is working as we would expect. So that's the good news. But what would be nice is if we weren't sending this heater on and heater off every time, because once the heater's on, we really don't need to send it again. And this is where the feedback comes in. So now I'm going to add a little bit of feedback to it. And we're going to start in the Nextion for this. And we're going to go to this function here, where right before we print it, if you remember, we have the variables on page 2, right here, heater 1 and heater 2, and they're both set to off right now. And so when we start the Nextion, I'm assuming, this is why I said this is only half feedback. What you also need to be doing is looking at the other end. For this example, when I turn it on, I know that the room is cool and the heaters are currently off. Now if I go to the timer, so if this value N0 is less than, which is what we know it's going to start at, and page 2 dot heater 1 is equal to 1, then we want to go ahead and turn it off. So if this value up here, N0, is greater than this value here, we know it's time to turn the heater off. But we only need to do it if the heater is currently on. If the heater is already off, we don't need to send off. So we're just going to send it if the heater's on. The minute the heater is turned off, we're going to have to send a signal from the Arduino up to let it know the heater's off. Then it doesn't have to tell it to turn it off anymore. The same goes for this down here. I have to put value in this too. The value of it. So in this case, if it's less than that, then we want to go ahead and turn it on. But only if the value, if it's currently off. Once it's on, then we don't have to do this anymore. So once it's on, we won't turn on. The logic can be a little backwards on this, but if you're willing to test with some LEDs, then you're fairly safe to do some samples and stuff. Then we have to do the same thing down here, but we'll use heater 2. And let's make sure I got mine. So it's greater than 1 and 1, less than 0 and 0. I think I got that. Let me compile this. And then I need to copy it because we would want the same logic on both timers. So we'll go back to page 1, timer, and paste it in. And now we'll run debug, and we should see less times we're sending the heater on and off to the Arduino. Now right now, since the Arduino isn't connected and that value is staying 0, it's just going to keep going. So we're going to need to go, I'm going to go ahead and turn this on and get it started. So now what we have to do is we have to go to the Arduino and send the signal back to the Nextion. How we're going to do this is when we get our data from display, if heater 1 is on, we'll turn it on. And after we've turned it on right here, then we'll send the signal up to the Nextion to change that variable so it doesn't send it anymore. You want to make sure you do it after So just in case there's an error and it doesn't get the signal for some reason or something happens, it just won't send it up, and then it'll go back through and execute it again. And it's just like up here where we send this page2.n1.val, we send page2.htr1.val equals 1, and then we send those characters. And we just do this on every one of these. Of course, we'll have to change this one to 0 because we're turning the heater off. And then this one needs to be 2 instead, because we're changing heater 2. And this one needs to change them both. So it's heater 2, and that val equals 0. So we're going to upload this, and then when we go back to the debug, it should just stop. So I'm going to upload this and go back and hope the upload goes. I'm going to clear this. Let me set this to string. And there you go. It seems to have stopped at this point. I'll pull up the Arduino serial monitor. And now you can see we're just getting these temperatures. But if I take heater 2 now, and I make this go above 80, this should turn the heater off. I'll go ahead and pull this up too. And there we got the heater off. The light went off, and it should be there too. And it only sends it that one time. And then when this goes back down, it will send it back. The next thing would be nice to know is maybe not send as many of these up all the time. If the temperature is the same, you don't really need to send it and repopulate this up here and send data every 2 seconds. So we're going to work on that next. I'll let this run and see if this temperature can go down when we come back to it. So we'll go back into the Arduino. This is where we send the line up to the Nextion display right here. So if we were to take, after we read this temperature, and we put in an if statement here, we're going to see if temp1 is not equal to temp1 last. And if it's not equal to it, then we're going to run this. And when we first start this, we set temp last equal to 0. So if they're not equal and it runs through this, we'll set it equal to it so that it won't run again until it's not equal again. So it'll send it, and then it won't send it anymore as long as they're of equal value. And we'll do the same thing down here. But just like up there, I've got to then set temp to last equal to temp 2. And then we'll upload this, and hopefully we will be able to tell that this isn't running as fast. I'm going to clear the output. The other thing is you shouldn't see how it goes 2 and 2? So that means that only 2 changed. Went from 72 to 73. Oh, and then there it turned the heater on, turned the heater off, because at 79 it needed to turn the heater on, at 81 it needed to turn the heater off. It's strange, I'm getting some fluctuations in these thermocouples that I wouldn't expect. They don't seem to be as stable as I'd like, and it could be the way I have it configured or something. I'll have to play with that a little bit, because it jumps quite a bit, and I don't have them, and they're just laying there. This one over here, I'm going to plug it in next just to see what happens, or heat it up next just to see if it reacts the same. Yep, heater 1 got turned off. I mean, it's acting exactly like we would expect, except for the sensors themselves just don't seem to be as fluid as I would expect. I'm going to time-lapse this, and we'll watch it come back down, and we'll see if it comes down better than this one over here. See if it doesn't jump around as much. Well, as you can see, it's pretty much jumping around too, just like the last ones. And maybe that's the way thermocouples are. I used to work for a refrigeration company who would use thermocouples, but we'd do long-term tests over hours. And maybe that's the best way to use these. When you actually use a sensor, sometimes you don't know how they're going to respond, or you have this idea of how they're going to work. I had one of these right here. I bought one of these sonar sensors here to use for another experiment that I'll have coming out soon, and it didn't act the way I thought it would either. It just wasn't quite as accurate as I wanted. It was okay, but it wasn't great, and I'll go into that in the video. I put a line of flight sensor, hoping that will work a little bit better, and I'll do a comparison on the two and show you what I found. But I don't want to deviate too much from the plot, but it's just interesting what you find out in these sensors as you do the testing. This output should stay the same even if we switch pages. So let's go to page 2 and then bring up this again. And let's just heat up one of these one more time just to make sure that it does change the way we would expect. And there you go, we got heater off, it's 83, which is just the same. So we have values where we've established on one page. If we go to another page, we can read those values because they're global, use them to adjust these sliders. Even though the sliders aren't global, nothing on this page is global, but it works. And it writes to the Nextion it writes to the Arduino no matter what page we're on. Plus we also tied in a little bit of feedback, so we don't have to send data as often as maybe we would if we didn't have that feedback in there.
Well, that's about it for this video. If you like what you saw, consider giving me a thumbs up, and also consider subscribing to the channel. Thanks for watching.